Chapter 12, A Dialogue on Memory Virtualization. So, are we done with virtualization? No. Hey, no reason to get so excited. I was just asking a question. Students are supposed to do that, right? Well, professors do always say that, but really they meant this. Ask questions if they are good questions and you have actually put a little thought into them. Well, that I sure takes the win of ourselves. Mission accomplished. In any case, we are not nearly done with the virtualization. Rather, you have just seen how to virtualize the CPU, but really there is a big monster waiting in the closet. Memory. Virtualizing memory is complicated and requires us to understand many more interesting details about how the hardware the OS interact. That sounds cool. Why is it so hard? Well, there are a lot of details, and you have to keep them straight in your head to really develop a mental model of what is going on. Well, we are simple with very basic techniques like base and bound, and slowly and complexity to tackle new challenges, including fun topics like TLBs and multi-level pages, and eventually we will be able to describe the working of a fully functional modern virtual memory manager. Neat. Any tips for the poor student in inundated with all of this information and the general sleeping drives deprived? For the sleep the deprivation, that's easy. Sleep more and it's probably less. For understanding virtual memory, start with this. Every address generated by a user program is a virtual address. The OS is just providing illusion to each process, specifically that it has its own large and private memory, and with some hardware help, and the OS will turn these pretend virtual addresses into real physical addresses, and thus will be able to locate the desired information. Student, okay, I think I can remember that to self. Every address from a user program is virtual. Every address from a user program is virtual. What are you murmuring about? Oh, nothing. I could pose. Anyway, why does the OS want to provide this illusion again? Mostly ease of use. The OS will give each program with the view that it has a large contiguous address space to put its code and data into. Thus, as a programmer, you never have to worry about things like where I should store this variable, because the virtual address space of the program is large and has lots of room for that sort of things. Life for a program become much more tricky if you have to worry about feeding all of your code data into small and crowded memory. What else? Why else? Well, isolation and protection are big deals too. We don't want the unerrant the program to be able to read or worse, override some other program's memory. Do we? Yes, probably not, unless it's a program written by someone you don't like. I think we might need to add a class on models and then epic to your schedule for next semester. Perhaps OS class isn't getting the right message across. Maybe we should, but remember, it's not me who taught us that the proper OS response to errant process behavior is to kill the offending process.